Well, Monday's here again. I thought I'd hit you guys with a little bit of engine performance stuff and a little pop test at the end. And this is a few little jobs that I thought were kind of interesting. And I didn't do all these jobs. Some of it I got from other folks, but it's really interesting stuff. And I like to analyze the repairs I get from other people and see if I can figure out, what I would have done if I'd been facing the same thing. How did they make their way to this conclusion that they reached? And did they go about it in the same way that I would, or do they have a better way of doing it? One of the funny things that used to happen whenever I was doing brakes, if I was I didn't do a lot of brakes toward the, last few years of my career when I specialized on electronics and engine performance and stuff, but occasionally I'd do a rear brake job. And it was funny to me how when I was doing brakes, if I had the car up and I was putting brake shoes on it, somebody would inevitably come by that, these other mechanics, they did a lot of brakes, they'd come by and they'd say, hey man, I do that a different way than how you do it. And I'd say, well, really, how do you do it? And I would back up and I'd let them do the work for me, and I would watch, and if I liked the way they did it better than the way I did it, I would adopt the way of doing it that they were doing it, because there's several different ways you can get to the same place. That's one of the things that makes Microsoft Word and the other Microsoft programs work as good as they do, is because you've got so many different, in their operating system too, is you've got so many different ways you can do the same thing. And it's always a good idea to have several different ways to attack something. But this particular one we're starting out here with is a 2001 Pontiac Grand Prix 3-point V6, and it came in with a DCP0404. It's set right after clearing, EGR related thing. Anytime you got a 4 series code, it's typically got to do with some kind of air. That's basically how that works. Something to do with the air. And but anyway, it was set right away after clearing. The customer noticed the engine stumbled on mild acceleration. Now the PCM compares the EGR position sensor with the desired EGR position when the valve is commanded open. If the difference between the EGR position sensor and the desired is more than 15% on one of these GMs, the P0404 will set. So it's basically telling it to open, and it's checking it to see if it did what it told it to do. Alright, so the EGR valve could be commanded open with a scan tool, and the engine only stumbled at idle when the EGR was commanded to 60%. Let's see, the PCM was actually struggling to try to get the EGR to work the way it was supposed to. So the EGR was removed, the ports were inspected to be verified to be clear. On one of these videos I showed how on some of these GMs, typically EGR is either going to be fed by a bunch of little ports, one into each runner, or it'll be fed right in behind the throttle plate, because what they're wanting to do, the design is that each cylinder is supposed to get the same amount of EGR. If one cylinder is getting more than the other ones, you're going to have a misfire, a rough idle situation there, a rough running surge, that kind of thing. The old Fords had these two solenoids on them, EGR control and EGR vent. We call them ERC and ERV because that's what the abbreviation was. And occasionally you'd have one of those that would surge, and if you unplug I would tee into the hose going to the EGR valve and pull a vacuum hose into the car with me, and I'd hold my thumb over it. And I'd be driving along, and when I felt that surge starting, I would remove my finger from that hose and vent the vacuum from the EGR, and if it cleared up, I would typically know there was some kind of an issue with that. Now, a lot of the earlier EGR valves that we came on those Fords came with various different little washers that were supposed to let more or less EGR go. You could calibrate the amount of EGR that was coming on a brand new valve, and they had a whole bag full of those little washer-looking things with various different holes in them. And so if you're getting too much EGR, you could choke it down a little bit with one of these little, putting a washer in there with a smaller hole, but you put in a little machined-in place to stake it in, and all that. That's, of course, sort of complicated in this old school stuff. But anyway, so the scan tool showed the EGR position was only voltage was only 1.75 when the valve was commanded to the wide open position, and the voltage at the sensor matched the scan tool data. So you notice you got a potentiometer here built in there. This is a 5-wire thing. You got a potentiometer built in there, and then you've got a little motor that's going to open and close that valve. That's what this is about. And so you can basically go and what he was saying. This guy that I got this from, he basically is kind of like, he thinks the way I do. If he sees a reading on the scan tool, you don't totally trust that. What you need to do, if there's any way you can, and it's a voltage reading, you need to go to the actual wire, and you need to back probe, and you need to measure the voltage with a meter live so you can compare it to what's coming through the network into your scan tool from the PCM, because sometimes the PCM will be confused enough to where it may give you bad information, so you compare real world to what the PCM's feeding you. Alright, this 2000 Pontiac Grand Prix, once again, replaced the EGR valve, position voltage reached 4 1/4, at wide open position, the DTC was cleared. That was a simple fix, but understanding how that EGR valve works has got a lot to do with how well, you know, EGR valves can stick, they can get clogged, they can get something underneath the pintle where they're trapped open, letting EGR through there when they're not supposed to be. EGR is not supposed to work when the car's idling. You know, some of your diesels and stuff will open the EGR when it's idling because it makes it idle a little quieter, but I'm talking about on gas burners here. 2000 Buick LeSabre Limited 3.8. When starting, the engine's got excessive kickback and runs really rough when it finally starts. It's also backfiring in the intake when it does start. When it warms up a bit and goes into closed loop, everything straightens out and runs right. Acceleration and performance are good. Okay? So, this is what you got going on here. Now, this is a 3.8. It's another 3.8. The last one was a 3.8 as well. And that 3.8 was kind of a workhorse of an engine, you know, but it had its own little spate of problems. Most of them were related to, you know, sensors and stuff. Now, this one here, this had been replaced already. Somebody had put a mass airflow, a throttle position sensor, a crank position, and cam position sensors. They put both of those on there. Intake air temperature, ignition module, and ignition module harness. Now, I didn't picture the IAT, but the simple fact was they replaced this module, which is under the coils. You see how each coil plugs into there, and they replaced that harness. They put all that stuff on there. You know, figure maybe we have a little pin fit issue going on here that we didn't know about and all. So this is what they were doing. Now, I have run into issues with these modules before myself, and you can typically, you know, if you troubleshoot them the right way, like I say, there's a bunch of different ways you can arrive at this thing. But the new ignition module that had been installed turned out to be bad, but it never stored a code. Live data showed electronic spark timing bypass functioning, but it wasn't. Replaced the ignition module with a new GM module, and it was done. Took care of that. I had one time that was cutting up and cutting out with one of those kind of ignition modules on it. And that one, what I did on that one, I mentioned it before, I took a timing light that had long leads on it, and I hooked it to the battery, and I hooked it around just one of the plug wires, and I brought it into the car, and I taped the trigger open so that it was flashing all the time, and I had it down on the floorboard so I could see it flashing. And we would drive it. This thing wouldn't run bad all the time, but when it started cutting up and running bad, that timing light blinking was not blinking steady when it was cutting up like it was when it was running right. So when it started cutting up, the timing light was blinking irregularly. That pointed me back to this module, and replacing one of those took care of it. I kind of like this setup here because you can look at, it's real easy if you're scoping to get your cam and your crank sensor signals right here, you know, back probing that pin there if you can get to it really good. Anyway, here's a 98 Ford Exposition 5.4 liter that idles too high. Now, I've seen other ones given this same problem for the same reason this guy's talking about. There's a dash pot function. The little carburetor, that was a dash pot. What it would do is when you open the throttle, this dash pot would extend, and then whenever the throttle came back, it would stop. I mean, in other words, that dash pot that extended would catch the throttle and it would lower it slowly. Well, that is a thing in the past, but the function is still there, both on electronic throttle body vehicles and on the idle air control. And what it would do is it would catch it and let it come back down slowly, whether it's you know, the stepper motor type or whether it's the current driven type like Ford's got. Whenever it's got to know you have let off the gas before it will come down from that dash pot function. So it basically is opening it up so that it's got a little bit faster idle when you come all the way back. Instead of slapping the throttle plate shut and sometimes causing the engine to stall or stumble, it will basically let it come down slowly. And it does that electronically, just like this silly thing used to do back when we had carburetors, and even some of the central fuel injection ones that had an injector or two in the throttle body, they had that little electric motor. You know, GM had the little electric ISC motor that would come out and in, and they had a tracking switch so that it would know when you let off, and it would wait and it would come back down. And then on some of them, they had a little relay that had a 10-second delay, each power relay, when you switch the car off. and it would give the engine controller time to go and do the no-touch starting setting and all that. Anyway, you might notice this guy put a TPS on it. Voltage is still the same at 1 volt, because the reason he did that was because he was noticing the TP mode was at part throttle even when he didn't have his foot on the gas. Now, I will tell you, and there was another one I had, if you ever see that kind of thing, if you'll disengage those connectors, make sure you keep them in order there, and with them poking up in the air, you're going to see beautiful little tight crimps on those terminals, and the copper will look clean. But if you'll take and solder those things, and I should have put a picture of that up here, if you'll just basically solder it where they're crimped, but make sure the terminals are standing up when you do, because if you got those terminals drooping down when you solder them, that solder will run down in the terminal and it won't plug in anymore. But make sure they're sticking up in the air, and you solder the little crimps with your soldering iron. Get it good and hot, get you some rosin core solder, some of that small stuff that melts real easy. Solder those things, plug it back in. You'll be astonished how many times you will actually wind up fixing one of these. I've seen that on mass airflow sensors, I've seen it on throttle position sensors, and I've seen it on some other connectors too, that if you just, all you have to do, if it's got just a whisper of a signal coming through there, and I'm not talking about tail lights and all that kind of stuff, I'm talking about whenever the computer has got to depend on a signal to be very, very clean and accurate, soldering those is better than a crimp. But a crimp usually will do it anyway. So what this guy wound up doing was he just popped the throttle position sensor on there. Ford had a deal where they wanted it to replace this connector for that problem, you know, because when you let off, it'd still be up there. And the TP volt, you know, like if the closed throttle voltage, which is recorded when you first started, is lower than this, like maybe it's 0.90, and you let off, and this is a little high because of the signal return having just a little whisper of voltage drop in there. Anyway, what this guy wound up doing was replacing the TP sensor, and it took care of it, and the scanner displayed, didn't display part throttle and idle anymore. It should say C/T if it was closed throttle. Chrysler Sebring LXi 3 liter. Now this is one of those Mitsubishis, right? Those Mitsubishis has got them, you know, funky all-in-one distributor things. Timing belt and distributor have both been replaced, and we still got a problem with it cutting out. All right, so this guy's lab scope pattern that he pulled up indicated camshaft and crankshaft patterns disagreed with Mitsubishi published waveforms. You know, whenever you were camming this kind of, you know, it'd be this right here would be the crank sensor, this would be the cam sensor, and that right there would be the ignition coil ramp. So you have number 1 right there that you got on that. So he confirmed that all the timing marks were lined up correctly, removed the reluctor crankshaft pulley assembly, and made sure the little reluctor plate on that pulley hadn't moved off of its little dowels, you know, because the little bitty dowel pins are supposed to keep it, and if it moves a little bit, that'll throw things out. And it turned out that we replaced this Chinese replacement part with an OEM distributor. Now, aftermarket supplied distributor assemblies for these are often a lot different from the OEM, so the best way you can do this is give the dealer the VIN number for that particular car, and you can get the right distributor. But you can get a whole bunch of different distributors that will all plug, you know, fit and even start the car, but they won't run right if those little optical plates are cut, you know, the little line. You got a couple of sets of these little slots cut in the plate, and on either side of the plate you got an LED. One of them is actually an emitter and the other is a detector, and it's actually shooting through those little slots in that plate. And you'll have one set of them that's got, like, you know, a bunch of little fine slots, and then on the inside you'll have some you know, coarser slots, and that gives you the signals that you need and all that. But anyway, that you might notice this one here has actually got a timing adjustment too when you got a slotted hole there like that, usually. And anyway, we'll talk about that another time. This 98 Chevrolet S10 4.3 would surge and cut out. But it only did it when you were accelerating in first gear, and it felt like a rev limiter go on. Now, I've seen this before, and I'm on more than a few vehicles. And this guy right here, what he found out was a little crack in that intake air tube. Now, that wasn't a photo that he took. It was one that I took on another one that I found. It was doing that. As the engine torques, it opens up that crack, and it lets unmetered air go in there that the mass airflow sensor is not aware of. and that causes everything to be skewed a little bit in the power loss. As it loses power, the engine rocks back on its mounts, closes that hole back up. So basically what you're feeling is a coming and going. I had actually seen one on a Ford Probe one time, and it was because the wire harness was really, really tight going to the mass airflow sensor, and when the engine would torque, it would try to unplug the mass airflow sensor, and it would do that. So, you know, anytime you're seeing something that's related to engine torque, then you're basically looking for something like that. All right, now this one right here was kind of interesting. It had a PO335 for crankshaft position sensor, a 642 for sensor reference voltage, 1 circuit low, and 2122 for APP sensor circuit. And it also lacked power, so this thing generally had some issues here. And one of the things this guy noticed, well, this is a simplified version of the wiring diagram that I actually put this together. It was included with a PO642 DTC diagnosis chart. All 3 codes could be set. See, all of them are getting the same 5-volt supply. Now, they've also got a signal return, and they got a signal going out. So the AP position sensor, the crank sensor, and the throttle body are all getting that same 5-volt supply. PCM feeds it out to them. See, that was the deal on that. So he says, well, he was not getting but 1.6 volts on this line. Even when he unplugged all of these, he still only got 1.6 volts here. All right, so, but this is supposed to be 5 volts. So did he have a PCM problem, or what the deal was? All right, so then he cuts the wire away from the PCM. Sometimes you have to do that in extreme circumstances, because you can't always back probe and all that. You can solder it back together, you know, if it's in a place where it's easy to get to. Just pick an easy place to get to. He had 5 volts when he isolated the PCM from everything it was feeding with 5 volts. So he said, well, what in the world is the wiring diagram leaving out? Well, it turned out the oil pressure sensor also gets that same 5-volt feed, but it was left out of that other, you know, code chart wiring schematic thing. And I have actually seen several of these go bad. That's a fairly common code on Jeeps and Chryslers. Is that oil pressure sensor. It's basically got 5-volt signal return and a signal going back to PCM. Disconnecting that sensor revealed the problem was within the sensor itself. So we put another one of those on there. Everything came up, the codes went away, and it ran good. Now this one here is a lot of fun. It stalled only when activating the left turn signal. And the customer also noted the left headlight was dim. Now this is taking a, you know, this is sort of leading you in the direction you need to go. The customer replaced the headlight, but there was no change. The stalling problem began to get worse and worse until it happened all the time when you turn on the left turn signal. I'm going to pause for a second here to tell this funny story that I may have told before, but I forgot. I tell a lot of stories, so I forget. One time I drew you know, whenever we would draw a work order at the dealership, they would, you know, run them through the computer, and they'd come out and they would have these repair lines. You'd have your first repair line, your second repair line, your third one, and then if there was more than 3, they'd give you another. So you'd have to flip through your tickets to find out everything that they expected repaired. Now sometimes a couple of repair lines would be referencing the same thing, only they didn't know that. They were just looking at symptoms. And so on the very first repair line on this work order that this service writer wrote, this service writer here was a humdinger. I mean, I can tell you a lot of stories about him. So he said, and the first thing I see on this repair line is unit won't start unless the left turn signal is on. And I said, that's the craziest thing I've ever heard of in my life. I wonder what the deal is going on. I have got to do that. It was the first repair order. It was on the first repair order line. And I got to digging, and when I finished digging about 45 minutes later, after I got into the dash looking around, I discovered that they had altered the wiring to make it work that way. So that in order to start that vehicle, you would have to turn on the left turn signal. And so I'm thinking, okay, here's a smart aleck that did this. I wonder why this is something they won't repair, because they obviously did it. So I went out there after having spent 30 or 45 minutes finding this, because it was tricky to find it the way they put it in there. And I says, why is this, are they wanting this fixed? Because it looks like they've altered the wiring and made it this way. He said, oh, I knew that. I was just telling you that so you would know how to start the vehicle. So he puts it on a repair line. I mean, the way you do that is you put a sticky note on there, and with a pen you write, this is wired so you have to turn on the left turn signal before you can start the vehicle. I just couldn't stand it. That was on a van. Anyway, so here we go on this Envoy. All right, all three components are grounded at the same location: the turn signal, the headlight, and look at this, the fuel pump. Okay, so the ground distribution for that, see, this right here is hardwired to ground, right? So this is kind of crazy, because look at how GM did this. They got the ground coming in from the top on that, you know, and then this power that's coming in from the bottom. I never liked it when they did that, but that's what GM did on this schematic here. However, look at G107. G107 also is for your headlamp, and G107 is for your marker lamp and your turn signal, right? All right, so what the deal was, it turned out this was corroded and rusty, and there was voltage that was dropping at G107, and so whenever it was able to get a ground through this park turn lamp bulb, then it would, the fuel pump would run just fine because it was able to ground through that bulb. But when you turned it on, that ground was gone, and the fuel pump would drop out. You know, and this was basically the that fuel pump relay coil is what it mounted to. And so you can see how the coil didn't pull a lot of current, but it was able to get a ground through that bulb, right? All right. What they did was wire brush the contact point on the engine block, replace the bolt washer. The headlight was bright, and the stalling problem with the left turn signal engaged was resolved. That was a lot of fun. All right, now here's your pop test. Let's go on this. In an OBD2 onboard diagnostic 2 system, when all enabling criteria for a given diagnostic is met, is considered which one of these terms? I'm not going to read the answers to you. Mike says running a compression test can be used to determine the condition of connecting rod bearings. Jack says a cylinder leakage test fills the cylinder with compressed air, and the gauge indicates the percentage of leakage. Who's right about that? Question 3. How did PCMs generally determine when to fire injector number 1 on a sequentially fuel-injected engine? Question number 4. Mike says all returnless fuel systems are electronically regulated. Jack says all returnless fuel systems have the regulator built into the fuel filter. Who's correct? Question 5. Which sensor input does the PCM consider most important for the fuel control on a speed density fuel injection system? Question 6. Air bubbles cause more problems for engines with returnless fuel systems because... Question 7. Mike says on a returnless fuel system with a tilted fuel rail, the cylinders fed by the lowest part of the fuel rail will skip if air gets trapped in the rail. Jack says the highest cylinder on the fuel rail will probably be the malfunctioning cylinder. Who is correct? Question 8. What mechanical measurement can be done with the valve cover removed to determine if a camshaft lobe is worn on a pushrod engine? Question 9. When air is present in the fuel rail on a warm engine with normal pressure and there are no visible leaks, what's the probable source of the air? What is volumetric efficiency? That's question number 10. Alright, let's talk about the answers now. This right here is called a trip. You can call it just a trip or a good trip or whatever. Basically, you've got to satisfy certain criteria because there are some things that cannot be continuously monitored on these OBD2 systems. The catalyst is one of those. It actually has to reach a certain temperature for a certain amount of time so it can be monitored so that the engine controllers, backup, the background manager can tell that it's working right. These engine controller systems have got foreground managers and background managers in their programming. The foreground manager is what does what has to be done all the time, really important. background manager handles EGR and stuff like that, you know. Question 2. This basically is, Jack is right about this. You're going to fill the cylinder up with air using a cylinder leakage tester. You don't pay any attention to what this gauge says, but before you ever put this in the cylinder, you're going to have it so that it's disconnected from the, you know, so that it's basically blocked. It's like a coupler on an air hose. And you actually, with when you make it, there's no leak at all going out of this hose, but you got your air plugged in, you turn the knob so that this right here is reading 0 when there's 0 leakage, and then whenever you plug it into the cylinder, you got to have the piston at top dead center with both valves closed is the best way to do that. And whenever you got that thing calibrated before you put it in, it's going to tell you how much leakage, cylinder leakage, that cylinder has. I used to have my students do that in a worksheet. It's really important to be able to do that. And if you're listening to the tailpipe in the intake, in the crankcase and whatever, and you open the top and you see if there's any bubbles coming up through the water, you can get an idea of where that compression is being lost, right? How do PCMs generally determine when to fire injector number 1? Typically that happens with the cam sensor signal. There are some weird setups on some European cars where they put about 80 volts down there to the spark plug all the time, and they're basically determining how you know, how much compression is in that cylinder based on what the deflection of that voltage. That is the craziest thing I've ever seen. I don't know. Some more of them may do it than I know about, but when I read about that one time about 20 years ago, I thought that was the strangest thing I'd ever heard. Kind of makes sense, but I will tell you that on some of these little 4-cylinder Kias, it's got the 2 little coil packs. You know, I'm not talking about cop coil, I'm talking about coil packs, where you got coils that are sharing companion cylinders. If you hook the companion cylinders up backwards, like, you know, you got 1 and 4 and then 2 and 3. Now let's say that you've hooked up 1 and 4 are being fired by the same coil. If you accidentally at the coil hook those cylinders up backwards, the opposite of the way they're supposed to be, you're going to have strange problems. So you got to make sure that you're not reversing, transposing the wires right there at the coil. I don't know if you've ever run into that before, but that is the thing. Okay, whenever you see any question that says all or always or never, you're basically going to say this is just hogwash and this is hogwash, and neither one of those guys knows what they're talking about, because a lot of the fuel pumps have got a regulator in here. General Motors likes to do that. Even on gasoline direct injected vehicles, Honda does that. They don't even have a fuel pressure control module for the, fuel pump control module that's changing the speed of the pump to give you your, you know, they don't even have a low feedback fuel pressure sensor. You know, Honda's really simple about the way they do a lot of stuff, and it works great. But Honda actually has their gasoline direct injection vehicle set up so that it's got regulated pressure coming right out of the tank all the time. You know, why add all that other hardware if you don't need it? Anyway, this one right here, that's the fuel pressure regulator, and the pressure coming from the tank actually pushes up on this, and the spring is calibrated so that, you know, the vacuum operates along with it, because there's a reason for that. But one way or another, this returns to the tank after going to the regulator. Now they got away from that. Heck, Chrysler was getting away from fuel system that was returned back in the 90s. They got away. They had returnless fuel systems way back in the early 90s. All right, which sensor input does the PCM consider most important for fuel control in a speed density fuel injection system? That would be the MAP sensor. So speed density or density speed will typically have a MAP sensor that will be the most important. Mass airflow sensor is the most important one, ones that have that. However, there are a lot of vehicles nowadays that have a MAP sensor and a mass airflow sensor, and it can actually, if the mass airflow sensor goes completely belly up, or if they're wanting to use the MAP sensor to see if it's flowing EGR, you know, they got a whole bunch of reasons they put MAP sensors on them now. They also, MAP sensor also provides barometric pressure information, and it needs that, you know, for altitude and all that. All right, air bubbles cause more problems for engines with returnless fuel systems because the air in the fuel rail passes through the injectors. It has to pass through the injectors. If there's a continual foamy bunch of air coming up there all the time, it's going to make them run. I was working one time, and I've mentioned that on one of my videos a long time ago. The dispatcher bought a Lincoln Continental. It was a 95 model. It had a V8 in it. It was sitting sideways in the car, And this son of a gun here had a sort of a rough idle to it. It really bothered him. He bought it with 15,000 miles on it from the Lincoln Mercury dealer, and it was a beautiful white car. I mean, just perfect. And except for this occasional rough idle, it would idle. It's supposed to run so smooth when you set a cup of water on it, you won't see a ripple. But that one had a sort of a rough idle, and it bothered him. That was the only symptom he had. It was a little bit of a rough idle sometimes. And so I connected the Service Bay diagnostic system to it, and I pulled up Power Balance, and I was totally astonished to see it had a walking skip. It was going 1, 3, 7, 2, 6, 5, 4, 8. It would skip on 1, then it would skip on 3, and then it would skip on 7. It was basically following the firing order, and it would do that over and over and over. You'd see the little tracks on the Power Balance. And so I was totally bumfuddled by that, and I called the hotline, and the hotline guy was as bumfuddled as I was. He goes, I have no idea what would cause that. That sounds like something somebody just kept pulling out of their hat off the top of their head. No, this is really doing it, and I'm watching it happen. And the only time it makes this pattern is when the engine's idling rough, and it doesn't idle rough all the time. And so the guy just said, I don't know, put a cam sensor on it. That's all he could come up with. But I got to watching, on that one there, because it was a returnless fuel system. It had a fuel rail pressure sensor, and it also had a place where you could put a fuel gauge. So I hooked the fuel gauge up to it, and I noticed that the fuel gauge, whenever it was doing this, was doing a lot of bouncing that it wasn't supposed to be doing. I'm not talking about just bouncing with the injectors, but it was showing a lot of turbulence in the rail, which indicates that there's air in there. But the resolution of the signal I was getting through the engine controller to the screen on the Service Bay diagnostic system was not high resolution enough to pick this up. And so hooking that manual gauge on there, watching that needle bounce, I said, this thing's cavitating, and it's getting air from the fuel pump. That's the only place it can come from. Mike says that on a returnless fuel system with a tilted fuel rail, the cylinders fed by the lowest part of the fuel rail will skip if air gets trapped in the rail. Jack says the highest cylinder will probably be the malfunctioning cylinder. Now, I ran into this on a Dodge. It was a Dodge van. It was a returnless fuel system. The number 1 cylinder, which was the highest one on the whole engine, it was just tilted a little bit. The fuel pump on that one was cavitating. There was air coming up there, and that air was congregating right at the number 1 injector, and it wasn't getting any fuel, and it was causing it to skip on number 1, and that thing beat me up for about a half a day before I figured that out. Now, if the fuel rail had been glass so I could see in there, I would have immediately known what I was talking about. But I just had to postulate this, figured out, how do you find that, I did a whole lot of work trying to figure out what was making it skip before I came up with the information that the doggone fuel rail had air in it because the fuel pump was cavitating. What mechanical measurement can be done with the valve cover removed to determine if a camshaft lobe is worn on a pushrod engine? If you take a dial indicator and you set it on a pushrod, and you bar the engine over and you compare that reading to what that, now this is only going to work if your lifter is not collapsed, right? But if you find out what the lift is supposed to be, and usually it'll be roughly 250 thousandths or something like that, or 240 or 260 or whatever, depending on the engine. It's different on every engine. Now, you're not as concerned about duration as you are lift, and if you actually measure it with that dial indicator, you can find a worn camshaft. Which we've done this, when I was teaching over there, and it works really well. You got some solid numbers you can come out with. You can compare one cylinder to another, and so on and so forth. And that's how you do that. Put a dial in. I got a picture of that somewhere, but I should have put it on the slideshow, and I didn't. And I think you've seen it before. When air is present, you got a cavitating fuel pump. You could have figured that out from the previous remarks I made about the other. What's volumetric? That's percentage of total airflow. If you had a way to capture all the air that theoretically that a 3-liter engine was capable of displacing, let's say that you took a garbage bag or some device that would measure how much air was going to, and you turn that engine 2 full turns of the crankshaft, and it's a 3-liter engine, you should see 3 liters of air going through this engine, right? However, unless it is a turbocharged or a supercharged forced aspiration engine, if it's just dependent on atmospheric pressure to let the air come through there, you're not going to get the kind of volumetric efficiency that's going to equal 100%. And so basically the atmosphere is supposed to fill that plenum chamber, and that plenum chamber is supposed to give each cylinder exactly the same amount of air. That's why they're designed the way they are. But with it having to go around these curves through the air filter, through the air inlet tube, and around through the intake and down into the cylinder, most of the time you're only going to, get a small percentage, compared to 100. You might get 40 to 60% of volumetric efficiency on a naturally aspirated engine. And there's all kinds of, interestingly enough, the porting and polishing of the heads that the hot rod guys used to do, where they would match them where there wouldn't be any bumps in there at all. There was some of the later hot rod magazines say that sometimes putting a gasket that chokes that down a little bit will help some, cause the air to pick up speed. And then they have these little flaps on the intake manifold flaps that will, whenever it's idling, they'll almost close that runner off, so it's only got a very small place for air to go through. And then whenever they open up, whenever you're driving hard and all, it gives you more volumetric efficiency. So there's all kinds of little tuning that manifold tuning does and stuff like that. Anyway, until next week, that's all. And let me know, if you don't mind, what your test score is. I hope you enjoyed that transmission video I released last Friday. Let me know about that too. But I'll be talking to you guys later on.